and on until what hits the A site? Stop codon. Release factors come in. That's the end of translation. So questions about this. Polyzones, open reading frame. These are two concepts that you would need to know. Coupling, right? Transcription and translation together. Questions about also the start and end of a, and that was a question on exam 3. So, which would be a good segue into our last old chapter, I guess. If you have an mRNA, right, and you have a mutation that affects the beginning of that mRNA. Okay. So here are my questions, or at least let me give you the key and I'll ask you the question. So here's the key. Okay, so here's my key. 5' N end, 5' C, etc. So here's the question. You have a messenger RNA that got a mutation at its beginning towards its start, if you will. Okay? Which end of the mRNA and proteins will be affected? Okay? So again, the start has the problem of the mRNA, the beginning of it. Okay? So which end would it be in the mRNA and the protein? Okay? So first of all, if it's the start of the mRNA, which end is that? It's the 5'. So this one is out automatically. You don't have to worry about it. The start is the 5. Because it starts with 5 and goes down. Which start is the protein? Which protein is the start? Whatever. You know about it. N. N to C. 5 to 3. I can't rhyme it better. N to C. 5 to 3. These two rhyme. These are at the bottom. These two don't rhyme, but these are at the top. So that's the answer right there. If it's the bottom, if it's the end of the mRNA, then it will be. So true or false, before we segue into the last one. True or false, messenger RNA is made 5 to 3 and read by the ribosomes 5 to 3. True. Messenger RNA, we discussed it earlier, it is made 5 to 3. All nucleic acids are made 5 to 3. And we just highlighted the fact that it is read 5 to 3, meaning the ribosome starts at the 5 and goes all the way down to the 3. So please keep that in mind. Any questions about? Okay. Chapter 9 has two parts, mutations and DNA transfer. Mutation, there will be some definitions, so I'm going to quickly highlight the most important. So for example, you do have to know the difference between wild type and mutants, right? Forward, reverse mutations, right? So for example, true or false, a forward mutation always changes the genome. In fact, let's rephrase. A mutation always changes the genotype, true or false? True. Always. Now always is a big word, so always usually, surely, I mean, there's going to be an exception to always. And the answer here is actually true. There is, by definition, a change in the genotype. A mutation always changes the phenotype. That's false. Not always, I mean, not necessarily. Okay? You also have to know the difference between mutations at each level. So for example, at the level of the DNA, you have a point mutation, right, which will change one base. And if it changes one base, it's either going to be a transition or a transversion. If it's transition, it will go from, in fact, let's start with this way. It's a fill in the blank. Actually, it's not fill in the blank here. These are my bases, at least DNA bases. Right? So here's my question. I have an A, right? And I know it's a transition. Which one of these results? So I know for a fact it's transition. So the A would have to convert to what? To be a transition? To G. Because I know it's a purine that will have to result from transitions. Because this is a purine. So it's going to be G. If the answer was, if the question was it's a transversion, then I'll have to have E, two of the above, because it could either be a C or a T. Right? That's a transition versus transversion. Now, at the level of the protein, you can have several. At the level of the protein, what can it be? The mutation can be called silent, in which case the amino acid that results is the, if it's silent, is the same because there's no change. Neutral is different but equivalent, close. Nonsense, if you go from an amino acid to a stop codon. Right? If it's a nonsense mutation, right? So for example, if you have, let me ask you this. You have a mutation that goes from UAA never mind, UAA to UAC, right? What is the effect on a protein? Let's say it's a fill in the blank, or, well, yeah, fill in the blank. You go from UAA to UAC. Now you should know what is UAA, because UAA is what? Is a stop. Now you might not know what amino acid is UAC, but you know for a fact, or you should know, that it's not a stop. So you go from a stop to a non-stop, you're making the protein longer. If it's the reverse, the protein is shorter. Okay, then we go into mutagens real quick. You have three types. You have chemical, right? Physical, biological. So let me do a flow chart real quick on it. I may have, skipped a couple of points. Doesn't mean that they're not going to be on the exam. Just sitting on the highlight. So mutagens real quick. Three types: chemical, physical, biological. Chemical, we discussed three types, right? We discussed base analogs, base modifiers, and intercalating agents. Base analog, modifier, intercalating agent. You don't have to worry about examples, but please know what they do. These two cause what? Point. This causes reading frame shift. Right? So they shift the reading frame. They insert, so that means they're going to shift the frame. Yeah. Physical, we discussed two types, right? Ionizing and non-ionizing, right? What's the difference? Ionizing is X-rays. This is UV light. This is strong. This is weak. This causes breaks in the DNA. This causes what? Pyrimidine dimers. So that's 2 points right there between this and this. Biological agents, quickly transposons, they cause frame shift mutations. So reading frame shift. So questions about this? Now the next half of the chapter deals with DNA transfer. So same thing, I'm going to use in fact this. So DNA transfer.